Imagine this: humanity's most powerful eye in the sky, the James Webb Space Telescope, peers across the cosmic void, focusing its revolutionary infrared sensors on a distant exoplanet 120 light-years away. The result? A discovery that could redefine life as we know it, or at least ignite a debate that stirs the imagination of every dreamer, scientist, and stargazer. The celestial body in question, K218b, is no ordinary exoplanet. It's a world of mystery, possibly cloaked in oceans, its skies laced with intriguing gases. But among these, one signal stands out: dimethyl sulfide, or DMs, a compound on Earth produced solely by living organisms. Does this mean we've finally answered the age-old question, are we alone in the universe? Or is this discovery another enigmatic riddle from the cosmos, requiring patience and caution before we can declare victory in our search for extraterrestrial life? Let's dive deep into the evidence, the debates, and the tantalizing promise of what might lie beyond the confines of our pale blue dot. The James Webb Telescope, a $10 billion marvel of engineering, has revolutionized our ability to observe distant worlds. Its cutting-edge infrared sensors allow it to detect the chemical makeup of planets orbiting distant stars, painting a picture of alien environments that was unimaginable just a decade ago. In September 2023, Webb focused its unparalleled capabilities on K218b, a planet discovered in 2015 by the Kepler Space Telescope. Nestled in the habitable zone of its red dwarf star, K218, this celestial neighbor has been under scrutiny ever since. The habitable zone, often called the Goldilocks zone, is the sweet spot where conditions might allow liquid water to exist, a key ingredient for life as we know it. But K218b isn't just a rocky planet like Earth. It's likely a Hycean planet, a theoretical class of exoplanet with a hydrogen-rich atmosphere and a surface entirely covered by a deep, global ocean. And it's within this alien oceanic world that the story of dimethyl sulfide begins. On Earth, dimethyl sulfide is a chemical compound produced exclusively by life. Specifically, it's a byproduct of phytoplankton, microscopic algae that drift near the ocean's surface. DMs is responsible for the characteristic smell of the sea, a scent that evokes memories of salty air and crashing waves. But why does DMs matter so much in the search for extraterrestrial life? The reason is simple yet profound: it is a biosignature, a chemical compound that, to our current knowledge, can only be created by biological processes. Its detection on K218b hints at the possibility of a thriving microbial ecosystem, releasing DMs into the atmosphere, just as phytoplankton do here on Earth. When Cambridge astronomers, led by Niku Madsudan, detected a faint signal of DMs in K218b's atmosphere, their reactions ranged from shock to cautious excitement. After all, detecting such a biosignature on an alien world could be the most profound discovery in the history of science. But as is often the case in astronomy, the devil is in the details. Let's talk about K218b itself. This exoplanet is located in the Leo constellation, orbiting its star at a distance of just 0.14 astronomical units, much closer than Earth's orbit around the Sun. However, its host star, a red dwarf, emits far less energy than our Sun, meaning K218b receives a similar amount of radiation as Earth does. With a year lasting just 33 Earth days, K218b could be a water-covered world teeming with possibilities. But while the presence of methane and carbon dioxide in its atmosphere adds weight to the idea of habitability, interpreting the faint DM signal is no easy task. Here's where things get tricky: the DM signature detected by Webb overlaps with methane in the planet's atmospheric data. Webb's near-infrared spectrometer, NIRSpec, can detect these compounds, but distinguishing between them at certain wavelengths is challenging. This overlap creates uncertainty. Could the DM signal simply be a misinterpretation of methane data? To clarify this, scientists plan to analyze K218b's atmosphere using Webb's mid-infrared instrument, MIRI, which can detect DMs at a different, less ambiguous wavelength range. This process, while promising, takes time. While we wait for the data, researchers are turning to theoretical models to simulate the conditions on K218b. A team led by Shang Minai at the University of California, Riverside, has explored how much DM's hypothetical life forms on K218b would need to produce for it to accumulate in the atmosphere to detectable levels. Their findings? For DMs to be observable, microbial life on K218b would have to produce it at 20 times the rate of Earth's phytoplankton. While this might seem implausible, the unique conditions of a Hycean planet could support such prolific biological activity. Moreover, these models suggest that once DM's concentrations reach a certain threshold, the compound and its breakdown products could form a protective layer in the atmosphere, preventing further degradation and increasing detectability. If future observations confirm the presence of DMs, it would mark an unprecedented milestone in humanity's quest to find life beyond Earth. Just one example of alien life, even at the microbial level, would answer a question that has haunted us for millennia: are we alone? But caution is crucial. As history has shown, extraordinary claims require extraordinary evidence. While the data from Webb is groundbreaking, it must be rigorously analyzed, cross-checked, and confirmed before drawing definitive conclusions. The lead scientist from the Cambridge team reminds us that even one unambiguous detection of DMs would be enough to revolutionize our understanding of the cosmos. Yet, the work is painstaking, requiring months of data evaluation and validation. As we await the final verdict on K218b, one thing is certain: the James Webb Telescope has opened a new chapter in our exploration of the universe. Its ability to peer into the atmospheres of distant planets has already yielded insights that were once the stuff of science fiction. Whether or not K218b proves to be the breakthrough we've been searching for, it is a reminder of the boundless curiosity that drives us to explore the unknown. In the grand tapestry of the universe, every discovery, every clue, brings us one step closer to understanding our place among the stars. If you're captivated by this journey, don't forget to like this video, subscribe to our channel, and join us as we continue to unravel the mysteries of the cosmos. The search for life beyond Earth is far from over, and the next discovery could be just around the corner.